We just saw how Southwest Florida is protecting and managing their most precious resource, water. We saw exciting new developments that's going to help them and help all of you. So let's move on to our second section, air, and a story about an organization that's moving people and products across great distances.
Official aircraft, arrival latest Juliet, departure latest Tango, current wind 190 with 11, gust 20, altimeter 3007.
The world's busiest airport handles more than 250,000 passengers every day. Getting every passenger into the air and back safely again requires an incredible infrastructure. 200 aircraft gates, 5 runways, 115 taxiways, 60,000 slabs of concrete, 25 miles of underground fuel lines, and more than 18,000 lights on the airfield. So to tell their story about how they're using WebGIS and 3D apps to improve efficiencies and empower everyone in their organization, please welcome from the Hartsfield-Jackson Atlanta International Airport, David Wright and Anthony Vasquez. Now, before you guys get started, I want to share with you a little bit of encouragement. Some people think that getting up in front of all these people is scary. It's really not. This crowd is friendly. Friendlier. If you want scary, think about an airport that's not enabled with GIS and the angry crowd that gets the message that their flight is now delayed. And so, without further delay, David.
Thanks, John. At Hartsfield-Jackson Atlanta International Airport, operational efficiency, customer service, and safety is our top priority. WebGIS has transformed our team from map makers to solution providers, allowing us to be agile, responsive, meeting the needs of a 24/7 workforce. Let's go on a behind-the-scenes tour of our airport. Our day starts with the GIS team replicating data on-premise and in the cloud, ensuring business continuity. Using ArcGIS Online, we deliver focused solutions such as the maintenance viewer. Our maintenance team wanted an app that gives them access to the entire range of maintenance-specific GIS data, such as airfield movement areas, utilities, and airfield lights. We use Web App Builder to configure this app to ensure a safe and efficient mobile workforce. Let's start our tour, meet our GIS users, and see where they work.
That was this is Ops 1. Ops 1, we are ready for the 27 left closure.
Runway 27 left, we show runway 27 left close at this time.
We're showing 27 left close to this time. Thank you much.
Every morning, the airside operations team uses a safety-critical app for their runway inspections. They're looking for any problems with the pavement, signage, lighting, or airfield markings. Collector for ArcGIS allows Jose, Phil, and the rest of the airside ops team to take this mobile app into the field to capture any runway problems. They share that data in real time across other GIS apps. To get real-time status, we also developed a dashboard that summarizes the problems and discrepancies by type, by location, and by priority. Next, you might think that cutting grass isn't such a big deal, but try doing this safely with 1,000 airplanes in your backyard. It actually takes a week to mow all the grass on the airfield, and the FAA actually inspects it. Jerome, our maintenance supervisor, uses Explorer for ArcGIS to monitor and manage the grass-cutting operations. We worked with him to understand his requirements, and we quickly configured a web map to use on his tablet. We have over 42 million square feet of airfield pavement. The management of pavement quality is an ongoing process. This app enables the pavement management engineering staff to better track, analyze, and budget for repair or replacement of concrete slabs. Our team provides GPS-based, high-accuracy field data collection tools. Using Collector with a survey-grade device, such as the Leica Xeno 20, we are able to bring our high-accuracy workflows completely into ArcGIS Online. Anthony, our GIS analyst, will continue our behind-the-scenes tour.
Wildlife encroachment on the airfield is a serious concern. Jeff in Airside Ops uses ArcGIS Online to see the concentration of wildlife strikes. By adding the locations of our mobile bird cannons, which we use to scare away the animals, we're able to improve safety. Early one morning, our deputy general manager noticed a lot of our streetlights were out. We configured a collector app for Rick and the Landside Ops team, and they're working with maintenance to address the issue. They discovered that someone was actually stealing the copper wire. We now know the extent of the problem and how to resolve it. Chief Cole, our fire inspector, is responsible for the inspection of over 7 million square feet. With limited staff, he wanted to prioritize the areas to be inspected. He was using a spreadsheet and wanted a map, but we gave him a web map, and he was using it the next day. Our web GIS isn't just for airport staff, it's also for contractors. To increase customer satisfaction, we had contractors install free Wi-Fi and iBeacons. We shared our floor plans in ArcGIS Online so they could accurately place the access points. They were blown away by how fast we were able to provide our data on their mobile devices. To help passengers navigate the airport, we're also working with GIS Inc. to develop interior wayfinding and routing. This dashboard provides metrics, and as participation increases, we'll be able to analyze traffic and flow patterns. Back to you, David.
And the beauty of our web apps, we didn't have to write a single line of code. Now let's move to the desktop, where our GIS coordinator, Brian Herron, has unleashed the 3D capabilities of ArcGIS Pro. Managing a complex airport requires not only a wealth of data and apps, but also a comprehensive understanding of three-dimensional space. This is evident when we look at our flight approach and departure surfaces for each runway. These surfaces define the maximum height for trees, buildings, and other obstacles. Take a look at runway 8 left. We recently encountered a challenge with the trees in this area. The FAA regulations are quite specific. If the trees intersect this 3D surface, they must be trimmed, or worst case, the runway might be closed. To better understand the situation, we'll use our 3D capabilities. On the edge of the runway, we can see the approach surface extending upward. We can clearly see that the trees penetrate this airspace. The next question, how many trees are affected, and what will it take to mitigate the problem? To answer this question, we'll run a geoprocessing tool to intersect the trees with our approach surface, splitting the trees into two parts. Those below the surface and those that extend above. We have 468 trees that intersect this approach surface, and now we know exactly what height we need to trim each tree. Overlaying parcel ownership, we now know exactly who is responsible for the trees. By the way, for those of you flying through Atlanta, we've mitigated the problems with these trees, and the FAA recently gave us a perfect score on our airfield inspection. The success of this project inspired us to reimagine the entirety of our airport in 3D. This doesn't have to be limited to airports. 3D is for us all. Here's how we did it. The first step used the FAA standard GIS data model and a set of cartographic rules to create our 2D base map. The second step was to add the structures on the airport property. We did this using Pictometry's 3D models for our tower, terminals, and concourses. And now you can begin to see the vivid level of detail, including our gates and our planes. The third step was to use procedural rules to render the other assets like signs and lights. Let's take a quick flight over to Taxiway Hotel and check out the signs. These were constructed from points and attributes in the database and rendered with a 3D rule. Our GIS data now becomes the signs that pilots see every day. To further demonstrate, with just a simple attribute edit, the sign regenerates. We can use the same process for every sign and every light. Procedural 3D generation. Procedural rules allow us to keep up with the dynamic changes of our airport. When an airline updates its fleet, we can easily ensure that our existing infrastructure, such as passenger boarding bridges, can support these changes. Basically, we just want to make sure the plane fits at the gate. The last step needed to complete our 3D airport was to convert our BIM, or Building Information Model, into GIS features. This allowed us to take 3D GIS inside the terminal. Now, we can begin to explore and see what's under the concourse. We can go through the windows and see what's inside. Or even go below and take a look at our transit systems. These were the 4 steps that we used to create a 3D GIS transformation of the Hartsfield-Jackson Atlanta International Airport. Together with Esri, our GIS team is setting a new standard for operational intelligence. 3D is where we live, and it's for us all. Come, join us. Thank you.